All right, so you have those different resources posted in there. I will separately post the slides, but then if you click on notes for assignments, I'll post, if there's more than one assignment, I'll do 2 different pages, but you click on this page and yeah, so there'll be a video for today when we go over part of the graphic organizer. That's what I'm recording right now. Most of the day you're going to be working on the math literacy assignment, and I have all the resources you need for the math literacy assignment, right? So the resources are there so that you can complete your assignments. I'll record a video at some point, and then I have 4th block off, so I'm going to try to make sure I upload that video and give the information you need about it every single day before I leave school. That's my goal. So use that to your advantage. Any questions about that before I move away from Schoology? We know how to get in there and all that stuff. Okay. So I want you to be successful, but again, remember, if you get too far behind, it can get rough. Alright, so I'm collecting the bell ringer. And so here's something that I will regularly do with the bell ringer is I'll collect it, and in class we'll go over what you all said. Because you will see each other's responses. Especially something like this, you probably got very different responses, especially for the first 2. And so we need to go over them to talk about these things, because here's the thing, we need to know what an algebraic expression is. Sad day, I don't see an algebraic expression up here. Tough, right? Okay, so I'm going to stop this class really quickly. I'm going to show you some of the responses that we got in other classes. Now, we'll point this out. When you only have 7 students, if we all make the same mistake or a similar mistake, we're going to be in a bit of trouble. Actually, hold on. Let me see if I can just... Yeah. So, here is second block. Alright. In this second block, I saw 1, 2, 3 expressions. So I want you to look up here. I want you to find 3 of something that are different than what y'all saw, or what y'all wrote. Think about what we saw in common in each of our answer choices. So I'm going to put your answers back up again. So look at your answers. Look at what they all have in common. And then compare that to second block. Which 3 are different and would be our expressions? Kylan?
I see 1, the 2 plus 3 squared. It doesn't have an equal sign.
So it doesn't have an equal sign, so that might be an expression? Are there any others like that?
That's what's different from all the ones in ours. Every one of our responses have equal sign.
Okay, so y was mx plus b, maybe. But I will point out, Kylan's whole argument was that there was no what here?
No plus.
No equal
No,
sign.
One
there's
right
no
above it too. Equal sign, right? So would we consider that an expression based on Kylan's ideas?
No.
No. Okay. Let's look again. There's 2 more expressions.
The one right above it.
Huh.
Yeah.
Any others like that?
Yeah, 3 times x plus 2 squared. Wait, does it have an equal sign?
That's a -2. Are there any others like that, or is that a set of 3?
That's the set of 3.
That's the set of 3, right? Notice I didn't tell you right away everything about an expression. We all made mistakes, and that's okay. And so I showed you a different example of things, and now we've identified 3 expressions. So here's the thing. We've talked about this before. What is math?
The study of patterns and relationships.
Y'all just wait on Kylan to answer the question. Remember, you have this in your notes. You should be going to look at your notes for these things. But it is the study of patterns and relationships. We got to know that. Because what do mathematicians do then? They
notice them.
They notice patterns and relationships.
Describe.
Then they describe those patterns and relationships. And then
they
generalize those patterns and relationships. Hey guys, to describe and to generalize, don't you have to use words?
Yes.
So if we don't know what this term expression means completely or perfectly, that can mess up our ability to describe and generalize. That can affect our ability to learn math well. And so we need to be able to define these terms really, really well. one of the other things I'll point out is students in this class, or this class and other classes, noted, hey, Mr. Kinney, I'm not used to doing homework or studying for math because I don't know how to do those things. Well, pick up the graphic organizer I passed out at the beginning of before class. There should be 4 of them. They look like this. Okay? That one, yep, that's a graphic organizer. Hey, what's the first concept on this graphic organizer?
Algebraic expressions and equations.
Algebraic expressions and equations, right? And then what is the first thing that you're supposed to put next to your concepts? There is the which lesson. If you know which lesson to go back to, you should have notes on that lesson, right? That might help you build the foundation. And I will point this out. I don't do it perfectly, but I try, in general, to start at the beginning of where I'm going to start within that unit and then go progress linearly from there, right? So hopefully, if I do it right, I'm going to do algebraic expressions and equations first, and then what are we going to cover? Solving and solutions, right? And so I try to keep it in order. It'll sometimes get messed up, but it's important to notice that you first need to identify which lesson this goes with. Now, you won't have a lesson in your notebook specifically for this. We might tie it into other things, but we can develop this here under major concepts and connections. So what we want to think about is how these ideas connect to other things. What does this concept mean? And maybe put some examples there. So, do note, don't write too big because you need to put expressions and equations here. When I look at that term, or the concept algebraic expressions and equations, which of those words ties in literally to the name of this course?
Algebraic expressions.
Algebra, right? Algebraic. What do we mean by algebra? Y'all, this is your second course taking algebra.
I told you at the beginning of the course I had a horrible teacher.
Okay, but have we even ever heard what the term algebra means?
No.
Never?
No, he didn't know what he was doing. He was a football player.
They never
Okay,
told
you only had him for 1 year, you had somebody else for the first year. Any ideas? You're dealing with algebra when you start dealing with variables.
Yeah.
When you start dealing with variables to represent unknown quantities, that's when we're talking about algebra. Okay? So what about an algebraic expression? That's where we're starting today. So what made these things expressions, but these other ones are not? What do we have in expressions?
Unknown values.
I mean, I got some known values in these expressions. I got a 2 and I got a 4. I got 2 2's here. Now, when you say unknown values, what's another way to say that? Because I would agree that there's one part of it that are unknown values, but what's the mathematical term for that?
The variable.
Okay, we got variables, right, in our expressions. What else do we have in our expressions?
Exponents.
We got some exponents, yes, and we're going to come back to that in a second because the exponents go with something else. But variables, are there just variables there? No, what else?
Separate terms.
Yes. Okay, let me point this out. That is only variables, right? Do these only have variables?
No.
Do they even all have variables?
No.
So they have variables and what else? Numbers, right? They have variables and numbers in our expressions. And you talk about an exponent. What else do we have besides exponents? So we've already talked about the variables, the numbers, the exponents. What have I skipped so far? What do you mean by the signs?
Multiplication, addition, subtraction.
Multiplication, addition, subtraction. Remember, an exponent falls within that, right? What are those called?
Operations.
Okay, so be careful. So we have operations versus the order of operations. Remember, the order of operations is the order that we do operations in to simplify an expression. Not in inverses yet. We're going to get there soon, okay? So we're talking about variables and numbers, and we've got operations involved, right?
Mhm.
Okay, so I'm going to help you get started on this. Because there's one word that we are kind of missing at this point, but this is important. So an algebraic expression, that is a combination of what?
Variables and numbers.
Right? Aren't we combining variables and numbers there? Okay. And so notice I guided you a little bit there because one, we're just getting started with this, but this is using our language to describe what's happening. This is generalizing what an expression is. Do you need a pencil? Paper?
I've already did that.
Okay, you know that you have a graphic organizer to write it on, right? Yeah, that's yours. That's to help you study. You don't need fresh paper. I've given you a graphic organizer to write all this information on. Right? The first term there is algebraic expressions and equations, right? So it's a combination of variables and numbers. Is that all it is? That's all we talked about for what an expression is? How are we combining them?
With the use of operations.
Right? Through operations. We're combining them through operations. Notice we have to include all those different details. That is what an expression is. But we may need to address some other things with this. What's a concept that expressions connect to? Something that you all tried to do for an expression when it's not an expression.
Equation?
One of you all said something. So equal sign, right? So equations, right? So can we have an equation and it be an expression? Can we have an equal sign and it be an expression?
Yes.
Well, I mean, did I count these as expressions?
No.
So can we use that as an expression? Nope. Doesn't work. Can't have an equation. Okay? So I'm going to take a brief second, pause from over there to add a little bit more detail and clarification to this. So I want to point out, if I have something like 2 plus 3 squared, right? There's no equal sign. We're all good with the fact that that's an expression, correct? Okay. And actually, let's do 2x minus 4. There we go. All right. So I have, because I'm going to use this, 2x minus 5. But if I say 2x minus 5 equals 100, right? That is an algebraic representation. But I can use words, and in fact, when I read it out loud, I use words, right? So 2 times x minus 5 equals 100. Another way you could say equals right here is. Right? 2 times x minus 5 is 100. So when I look at that, ignore the math, think about English. What would you call this in English?
Sentence.
Is that true? Is that a sentence? Does it have a subject and a verb? Yeah, it's got an equals there, doesn't it? That's my verb, or an is. So a sentence, another way to say a sentence is it's a statement. So if it's an equation, it's a mathematical statement, and we'll get into more detail about that in a second. The reason why I bring up this idea of statement and not just an equation is, what if it was 2x minus 5 is greater than 100? Would that be an expression?
No.
Yes? No? Kylan was saying no, right?
No.
You don't think so? Eric says no too. Eric, give me a reason why. Why are you thinking it's not an expression?
Because the little gator sign right there.
What is that gator sign called? Does anyone know? Okay, so that specific sign is greater than, right? So we would read this as 2 times x minus 5 is greater than 100. I'm going to come back to that in a second though. But I would say it could be this, which would be what symbol? Less than. This would be greater than or equal to, and then this would be less than or equal to, right? What is that group of symbols in general called though? It starts with an I. Math is a language in a lot of ways, right? Does anyone know what another word for an equation is? How about equality? Right? And then you just said that these things are called inequality. Hey, does anyone know what the prefix in means? Not. Mathematicians are not trying to be tricky. They're not trying to make it hard for you. They're telling you literally what it is. An equation is an equality. These are not equal, so they are not equalities. That's it. So, knowing that this is not an equality, but is it still a mathematical statement?
Yes.
So equations are mathematical statements, inequalities are mathematical statements, so are these inequalities expressions.
Yes.
The inequalities are expressions?
Wait, no.
Okay, so let's backtrack just a little bit because I think I moved a little too quick for a couple of these things. Remember, an equation is also called a statement, a mathematical statement, which is why it is not an expression, right? And inequality is also a statement. So is it an expression?
No.
Notice how this is a sentence, right? We write it algebraically with these symbols, but if you read it out loud, you would read it this way with a verb in there, is greater than. That is a mathematical statement. So when I come over here, not only do I want to say it's a combination of variables and numbers through operations, we also want to say it is not a what?
A solved statement.
It's not a statement, meaning it's not an
Equality.
or inequality. Remember, we're trying to define expression, right?
Inequality or inequality.
Okay, so it's a combination of variables and numbers through operations. So it's a combination that is not a mathematical statement. And if you're already good to go on the fact that a mathematical statement is equality or inequality, you don't have to write it. But if I were you, and you're not already good on that, I might put in parentheses equalities and inequalities. So it's a combination of variables and numbers through operations that is not a mathematical statement, right? It's a combination that is not a mathematical statement. It's not an equality, not an inequality. Yes, sir?
So as long as it's not a statement, it's
Expression.
Okay.
I want to 100% say yes, but and the only reason I'm not is because I may be missing something or not thinking about something. But for this class, yes, it's an expression as long as it's not a mathematical statement. Yeah. I'm just trying to think of an example that would not hold up, because when I give you a proper definition and you ask a question like that, I want to make sure that I'm not missing anything. But I believe that is correct. Yeah. I'll think about it and let you know if I am incorrect on that detail. Okay. So let's go back to our stuff. So then I asked you to make an equation. 2 plus 8 equals 10, 25 plus 3 equals 28, 3x plus 4 is equal to 12. I'm going to just erase this. Alright, does anyone see any of these that would not in fact be equations but might be expressions?
3x plus 5.
3x plus 5? So someone got there for this one, but is that an equation? No. What does an equation need? It's gotta have an equal sign, right? We know it's gotta have an equal sign, but let's go into a little bit more detail than just it has to have an equal sign. What is that equal sign in between? Right? Because it's not just, hey, it's equal. What does that mean? What's equal?
The values on either side of the equal sign.
The values on either side of the equal sign? But what about right here? That's not a value. What would we call that? Notice I haven't gone all the way through. I'm stopping here. 3x plus 4. That's an expression, isn't it? What about this? What's on the left-hand side? What about on the right-hand side? So that equation is saying that two expressions are what?
Equal.
Oh, that's what an equation is. And we can consider, we can say two expressions, or an expression and a number, something like that. So what I would write down, I'm not going to write it on the board right now, but again, you are supposed to be defining these things. I'm going to ask you to reflect on these ideas at the end of most days, and I'll go ahead and tell you. The first two concepts on that graphic organizer, that's your homework tonight. Filling them out. You already got expressions. So what should you write down for an equation?
A combination of two expressions
That are equal to each other? How about instead of a combination, what was another word we were using over there regularly? A statement, right? Remember how we said it's a sentence? So it's a statement that two expressions are equal. That sounds like a good, strong definition to me. And it's important to understand those two different things because an equation involves at least two expressions. And an equation is going to be worked with differently than an expression. So we got to know those two different things. We got to recognize those two different things. All right? And don't forget, if you forget or you get home and you need to rehear the definition or me going over notes, different things like that in class, I recorded the direct instruction part, right? So you can go back there, especially if you miss a day of class, if you miss class because you're asleep or something to that effect, that'd be really helpful. I think that's it there. So now let's look at the last question. So solve 2x squared minus 5 is equal to 27. I got x equals 4, 8, negative 128. I don't know what the last one is. It's an equation. I'm not sure where we got that. But I want to ask this, okay? What do I mean by solve? What do I mean by solution?
Find the solution would be what makes the statement true.
Ah, what makes the statement true, right? Okay.
And then you said solve, you mean to find the value of the unknown variable, right?
Okay, so not just find the value of the unknown variable, but find the value or values of the unknown variable that do what to that equation?
Make it true.
Make it
a
true.
Statement.
See how solving and solution play a very important role into the idea of an equation. Okay, so how can I figure out which of these is the correct solution or is in fact the solution?
You could plug it.
Oh, it's got to make the equation true so we can plug it in, right?
Yes.
Okay, let's start with that 8. Just because 8 is the most common answer. We got 3 of us who said 8. So pick up the calculator, type in, right? Because I could, well, before I get too far, let me say this. Could I do this by hand?
Yes.
Yes, but guess what? You're not in elementary school, you're not in middle school. I don't care a ton about whether you can do all of that by hand. What I care about is that you understand what a solution is, what an equation is, and what an expression is. So, can you type this whole thing into the calculator?
Yes.
Yeah, do that. Put 2 and then parentheses 8 raised to the second minus 5 equals 27. What happened there? By the way, really quickly, you see where it says clear in gray? So if you hit control and then clear, it'll take all of it away instead of you having to do it repeatedly. Alright, so type that equation in. Let me know if you need help getting that equation in there. Chase, Deja, you may want this information. It'll help you. Equals. Huh. So, is 8 a solution?
No.
How do you know?
Because it's a false statement.
Oh, and the calculator even told you it was false, didn't it? Oh, yikes. Okay, so that's false, so 8 is not my solution. How about 4? Now, before you start typing that equation in again, don't type it. Scroll up, hit the up button until you highlight the equation that you want, and then hit the enter button. What happens? You want the whole equation highlighted, so do this. See how the whole thing is highlighted? Scroll, you see how the whole thing is highlighted? Hit enter. So highlight that entire equation, hit enter, and what does it do? Copies it and it brings it down, doesn't it? Now, go modify that 8. What should we put instead of 8? 4? Okay. What's it say? For the 4?
True. It's like true.
You be careful. That says times -5. Because you put that button, didn't you? That's a negative, not a minus.
It's like true.
We gotta learn from that. Alright, so that says true. So is 4 a solution? Alright, so 4 is a solution. Okay, for those of us who got 4, can anyone tell us how we got there? By the way, does anyone recognize this equation?
Yes, it was from like Desmos or one of the.
It was that blue Desmos homework, right?
Yep.
We've seen it before. Yes, sir. No, you're never allowed to use restroom ever again. Ever. Even when you get home, too bad.
What you did?
Go.
I was breathing.
You can go to the restroom real quick. Alright, so what can I do to solve this equation?
I added 5 to both sides. And
Okay.
then after I added 5, I got 32 and 2x squared, and then I divided by 2 and got 16 equals x squared. Then I took the square root of x and 16 and got x equals 4.
So, there are other details I would want to add to this, but Eric, can you tell us why we added 5 here? Okay, it does have to go on both sides of the equal sign, but why did we add 5?
Because you gotta go across the equal sign.
Well, that's why we did it to both sides. Why did I add 5 in the first place?
And get the x alone.
Okay, so how does it do that?
You add it.
Huh?
You add it.
Okay, but why does that get us closer? How does that get us to 2x squared? What happened? If we can't answer that question, and we're just doing without understanding why, that's when we need to ask questions. Kylan, do you know why we're adding 5?
I was gonna say to get the x isolated, but then like to isolate the x, you would have to add 5 to both sides and cancel out the 1 5 that's on the side of the x to make.
Okay, well, let's slow down. Let's talk about that language again, because this is important. So you said that this is going to cancel out, and I guess you would do that, right?
Mhm.
Okay. But right here, why did we divide by 2?
To get the x by itself, because when like that term is 2 times x squared, so the opposite of multiplying it would be dividing it, and we're supposed to divide to get the x by itself so that we can find that.
So you're saying that these 2's do what to each other?
Cancel out.
But hold on a second. Those are very different cancelings, aren't they?
Yes.
So should we use the same term to describe very different things? And so notice this is where I'm going to support you to develop your language a little bit more. And we're used to just saying canceled, but it's more than just that. And we need to be careful with the language also. The word opposite in mathematics only means one thing. What is the opposite of 5?
-5.
So then how is division the opposite?
It's not exactly the opposite, but like when you're multiplying, you're taking a number times another number.
Mm-hmm.
And when you're dividing, you're splitting, well not splitting, but you're piecing out the value.
Do this for me. Look on the graphic organizer. There's a term there that is more mathematically accurate than opposite.
Inverse.
There we go. When we say opposite, the opposite of 5 is -5. That's the only opposite. But the inverse of multiplication is division. That means the operation that undoes something. The inverse of subtraction is addition. That means it undoes something, right? But it's also important to notice, right? It's not just canceling. What's negative 5 plus 5?
0.
What's 2 divided by 2?
0.
One.
That's why you can't just say cancel. Because that's very different, isn't it?
Yes.
In fact, you don't want a 0. What would 0 times x squared be?
0.
I don't want a 0 there, I want a 1. Because 1 times x squared is x squared. So it's important to develop our language there and understand the difference between opposite and inverse and what we call the identities. Notice we're making zeros and ones. When you take a square root right here, what did you just make the exponent? A 1. When you're doing the inverses, you're creating zeros and ones to get that variable on its own. Okay? Now, we're going to go into a lot more detail about that tomorrow. That's that process of solving. What I want to point out really quickly though is, we already put in a 4. Make sure you have parentheses clearly there because you haven't done that yet, but I want you to test this number, negative 4. Why are y'all retyping it? You know you can just scroll up, hit enter, and bring it down, right? It's okay if you've already been retyping it, but make your life easier than it has to be. What does it say?
True.
Oh! So not only 4 is a solution, negative 4 is also a solution. So that means with the work that we did right here, we missed something. And that's important. And we're going to go into details like that tomorrow. We're going to look at the Desmos homework activity when I give it back to you tomorrow, and we'll be getting the MacBook cards from the library so that we can use them. Yes, sir?
Does 4 and negative 4 being a solution have something to do with the absolute value?
Not as much as the absolute value. It is similar to this. I will point this out. What is the absolute value of 4?
4 and negative 4.
What is?
Oh wait, never mind.
What's the absolute value of negative 4?
4.
So you see how the absolute value of both a positive and negative get the same thing here, right? What is 4 squared?
16.
16, right? What's negative 4 squared?
16.
Because it'll be negative 4 times
Negative.
negative 4, and what's a negative times a negative?
Positive.
So do you see how that squaring action gets the same value here? So it's similar to the idea of an absolute value, but it's because when we square, whether it's positive or negative, it becomes positive. And we'll get into that tomorrow more. Okay? But that was part of the whole point of the Desmos activity. Alright, we got to get to y'all's lesson for today. You already have all the resources for this. So I do want you to notice we're supposed to start with what is math. We already addressed it. We already did a short look at the graphic organizer. Remember, you need to fill out those first 2 words. Hopefully